So today I'd like to give you sort of additional information about sort of what are the skills, jobs, and degrees that are best to sort of enter the quantum workforce. We heard a little bit this morning from a few folks and give you a bit broader view where we surveyed and interviewed up to more than 70 individuals and companies. So that's what I'd like to do today. So generally what I'd like to sort of questions we'd like to answer with these data really start off with like, what are the job opportunities in the quantum industry in terms of the types of jobs? Not the numbers, we don't have that quite yet, but we want to know what are the types and opportunities. And what sort of skills and knowledge are needed to be successful in these types of positions? In addition, how then do you gain those skills and knowledge through what degrees, and what are sort of folks in the quantum industry really looking for? So that's what I'd hope to cover today. So all of the results that I will talk about today come from two studies of the quantum industry. The first study was done at the University of Colorado. That's where I'm a faculty member. It was qualitative. So we interviewed 21 people from different companies. So it was very rich information. It was open-ended, and this was conducted in the fall of 2019 to give you a sense of when this was done. Then last year, through the Quantum Economic Development Consortium, the QED-C, sent out a survey and got responses from 56 companies about sort of multiple choice closed response about what sort of jobs and skills that they were looking for. So everything I will present today comes from these two studies. So really to jump right in, one of the first questions that people often ask is like, what jobs currently exist, right, in the quantum industry? What are those roles? And what is that sort of distribution of jobs predicted to be, say, over the next 5 years? Things are moving so fast, we probably don't want to predict beyond about 5 years. So if we look currently, what are the career opportunities? So of the 21 companies that we interviewed, you can see sort of the breakdown of what types of roles they had existing in their company in the sort of quantum domain. Almost all companies had, an engineer or something roughly called an experimental scientist, with about half some more theory. So there are about 5 key technical jobs that we sort of identified broadly, from theorist, experimental physicist, a technician, and applications researcher. You notice almost every company had an engineer. So if we kind of break down, what are we talking about when we say engineer? Somebody mentioned before, there's no such thing really as a quantum engineer. What these folks have degrees and are typically acting roles as electrical engineers, software, mechanical, and optical are sort of the main types of engineers that we're seeing in today's workforce. Then thinking a little bit about the future, what are companies going to be hiring in the next 2 years and the next 3 to 5? So in 2 years is shown in orange, and 3 to 5. So this is the number of companies out of the 57 that were surveyed, and these are the types of job titles that they're looking to hire. So this doesn't mean that throughout the industry there are mostly going to be experimental physicists hired. It just means that's the majority of companies are looking to hire those folks. And so there's quite a lot of range of types of job titles that they're looking for. I think an important thing to note here is the difference between 2 years and 3 to 5 isn't significantly different, which really says to us that the sort of distribution of the types of jobs isn't going to be radically changing. So the types of activities these companies are going to be engaging in isn't going to be radically changing over the next 5 years. So preparing yourself for a job in 2 years or 5 years, it's still a valid sort of career path. So I think that's really important. Thinking now about what sort of skills and knowledge are needed in terms of, do you need a broad set of skills, narrow, and what fraction of these are actually quantum related? So if we look at common skills across quantum jobs, we asked all of our interviewees sort of what are their main skills that they think when they think we're going to hire somebody in quantum. Well, almost all companies said, look at this, coding, and that's classical coding. That's not sort of, quantum error correction coding and things like that. So classical coding, statistical methods for data analysis, laboratory experience, electronics, troubleshooting and problem solving materials, and quantum algorithms. So you see, right, the industry is really a lot focused on a lot of these really sort of classical skills. Classical coding and sort of hands-on experimental skills are really desired broadly across the industry. But of course, we want to sort of dig in and look at that on a sort of a job by job basis. And so we've defined something called a consensus skills. That says more than 50% of people who said they're going to hire in that job said that's a primary skill. So what we have here are all our jobs on the y-axis, and this is the number of consensus skills. So for some folks, circuit designer, applications architect, error correction, there's quite a few skills that are primary skills, up to four main skills. For some other jobs, there's basically a primary skill that they're looking for. There are other things they're looking for, but that's a primary skill. And I think what's really interesting is looking at the difference of how many of these skills are quantum based versus more sort of traditional STEM type skills. And what you see here is in the blue color here, these are the quantum skills. So overall, there's a lot of skills that companies are looking for that are sort of maybe a little bit more traditional. And it really depends based on the type of role you see. Error correction scientists, 3 out of the 4 skills are really directly quantum related, but some others are not. So that's one thing to take into consideration. Excuse me. Question 3 is, are there sort of well-defined categories of jobs based on skills and knowledge required? And so this is important to think about broadly beyond sort of hardware. So what we have here, this is a correlation matrix. These are all on both y-axis and the x-axis, all the possible types of skills: electronics, digital circuit design, business development, error correction. And we looked at the correlation between these skills. So reds are positive correlation and blue are negative. And you can sort of see this is somewhat block diagonal, right? You see 3 main sort of types of skills and knowledge that are grouped together in different positions. And so if you start to read what is these types of skills that are positively correlated, you can see sort of 3 distinct categories of jobs. So up here, this big block, they're all sort of hardware type skills, from device testing, quantum sensor physics, circuit design. Then in the middle, we have product development, business development, sales and marketing. So there's really a business core in here. So sometimes this is often forgotten in the quantum discussion. And finally, down here in this final box is more sort of the software type, error correction, applications design, DevOps, database design, things like that. So this is telling us a lot that there are 3 core types of positions, and you don't have to have all of these skills to enter the quantum industry. You can focus on maybe the more software, hardware side, or the business side of things. All right, so moving on to question 4, sort of what are the degree levels needed for the different job types, right? I think we were hearing a lot of questions about this earlier today. And so here, once again, on the y-axis, we have all these different types of jobs. And then what percentage along the x-axis do companies want sort of a bachelor's degree here in purple, a master's here in red, or green and PhD? You can see this varies widely by the type of position, right? So if you want to be an error correction scientist, a PhD probably is probably the way to go. But there's a lot of jobs that have over half of the predicted employees have even a bachelor's or a master's degree. And so there's quite a large spread here. There's, except for, maybe really up at the top here, you can see that you can enter the workforce at these different levels with different degrees. And I think that's important to remember, that we're not all just hiring PhDs in physics. So if you think about more specifically the roots into that, like what types of sort of disciplines, we can break this down by looking at, here's the degree subject. So are you, basically a physics major, and sort of the degree level, associate, bachelor's, master's, PhD, and postdoc. Each one of these boxes represents a company that hires in at this different level. So if we look here at sort of the bachelor's, we have primarily people who have a bachelor's in physics. They're called engineers and experimental scientists. Those are the dominant ones. PhD in physics actually have a large range of roles, everything from applications researcher right down to engineer. So you can look at physics. Engineering is more sort of skewed towards the bachelor's level. And, there are a lot more technicians and engineers, fewer experimental scientists until you get to like the PhD level. We can look at this in terms of computer science. The 21 companies that we interviewed didn't have a lot of computer science, but you can see a large range of application researcher now for computer science. There's a few in chemistry and math. So you can think of where your sort of disciplinary degrees are and where is that leading you into the different types of positions. So based on all of these data, what are some recommendations, right? So generally the US quantum industry, right, it's growing. There's a variety of future positions available, but not all require specialized quantum knowledge and degrees. So we're not just hiring PhDs and postdocs in physics, right? It's much broader than that. I think that's really encouraging. I think that's what we've heard earlier today. So a few things from these data. One is hands-on experience is desired, right? So through internships, research experiences, and formal courses, right, are really useful to gain a lot of the skills. And I think sort of the habits and of mind of being in sort of these types of roles, this idea of resiliency and creative thinking, I think come a lot more besides the sort of technical hands-on skills. Another really important point is that not all folks who are working in quantum information science and technology need a PhD in physics, right? I really want to stress that because I think that was some of the initial where we originally started. But becoming quantum aware by taking sort of a couple of courses in quantum information science and technology actually can make you very employable, right? So being able to understand what entanglement means and have that conversation, being quantum conversant, I think is also very important for a lot of roles, right? Still focus on traditional STEM skills. It's not all quantum, right? We need folks that have all of the traditional skills. We need a spectacular RF engineer, right? Who can talk to others about qubits and entanglement. Those are really also in demand. This was echoed earlier. Don't worry about trying to become a quantum engineer. We asked 21 people what their definition of quantum engineer was, and I'm pretty sure we got about 21 different definitions. This is not a well-defined role. It can mean many things to employers. So remember, apply based not on titles, but on skill sets, right? What sort of experience and skills can you bring to a position? Don't worry if it says engineer and you're a physicist, or experimental scientist, right? If you're an engineer, right? It's the skill set. And so these job titles often don't quite match up, depending on different companies have different definitions. So that's a really important point when you think about, I'm going to start applying to the quantum industry. Great. So all of this work was done both at the University of Colorado by postdoc Michael Fox, as well as the QED-C Workforce Task Force that was led by CLM Mersbacher and others. There's a QR code for a paper on some of the results that were published, and we're hoping to get the second study published soon. It's on the archive. Great, thanks.
Well, thank you very much, Heather. I think you just reinforced that same message that all our speakers have been saying today about there are so many opportunities out there. You do not need to be a PhD scientist, and you don't have to have quantum listed in your education in your educational title. So that is wonderful news. So we did have one question, and then I'd ask Ashley, could you just talk to us a little bit more about what QED-C is?
Yeah. Myself, you want me to answer that? Yes.
Yeah, if you wouldn't, Mike, because you referenced QED-C, and I mean,
yeah,
it's a consortium with a lot of really key players in it, and I think it would just be good for the audience to understand who they are.
Right. So QED-C was sort of initially a mandate from Congress to NIST, who hired SRI to develop this consortium of folks who are working both across academia, national labs, and industry, working on quantum. And there are different components. There are different task forces and technical advisory committees that work on, say, quantum sensors or quantum computing and various things. There's also one on quantum education and workforce development, which is the one that sort of worked on this survey, which is really trying to understand the space of sort of what we need to do across the US to really bolster these ideas of quantum education broadly. So it's a large consortium of all stakeholders in quantum in the US.
Great, thank you. Okay, and we had another question. You mentioned coding didn't refer to quantum error correction because you mentioned that. I was wondering how heavily did you see quantum error correction, if at all?
So we definitely did. That was one of the roles that we saw, the types of jobs. Yeah, I know. So they're sort of very specific sort of error correction scientist was a very specific role that we have seen. Some 10 to 15% of the companies are looking to probably hire in quantum error correction in the next 5 years.
Perfect. Okay, and we have one more question. How about the opportunities of people from electronics background?
Yeah, and we heard a lot from our interviews that this was a really strong place where they're looking for folks, especially people with more analog RF type electronics background. So if you're an awesome electrical engineer, go and take, one course or two courses to get familiar with the language and the idea of entanglement of qubits and this sort of basic quantum. But they're really much in demand for what we heard from our interviews.
Great. Okay. You mentioned how we could consider becoming more quantum aware by taking 1 to 3 courses in QED-C. How can we do so?
Yeah, I think there are going to be more and more growing opportunities to take courses through sort of certificate and professional master's program where you don't have to go and get a professional master's, but many universities are starting up programs where you can go in, and these can be remote classes where you can take some introductory sort of quantum technology courses through all these different universities. So taking 1 or 2 or 3 of these sort of intro courses. You don't have to be, engaged with the university. Taking these individual courses, I think, is a real good opportunity. And those are really starting to come online this fall and will continue to grow.
Wonderful. Okay, and the last question. I am looking to combine the disciplines of computational science engineering and quantum computing information science for the design of algorithms and models for interdisciplinary purposes. Is this possible? This seems like, this sounds like a question that Nathan Baker can answer. Okay, maybe we'll, unless you have an answer for it, maybe we'll turn that over to Nathan, or Heather, feel free to give it a shot.
All of these types of combinations, I think there was echoed earlier, the idea that there are so many different opportunities, and having these skill sets that you bring together actually is really powerful. So my answer would be yes, absolutely. There are opportunities for things like this.
Okay, wonderful. Okay, well, that was our last question. Heather, thank you so much. And just for the audience, you went through a lot of great data here. And so we will be posting, Heather's been gracious to allow us to post this recording of this presentation on the event website, post the event. And so you'll have more time to review it a little bit more in depth. So thank you very much. I appreciate it.